Hi, everybody. Thanks so much for joining us. My name is Jeff Barnett. This is my buddy Kent Morris. We're going to talk about Lighting 101. This is lighting for non-lighting experts. Before we do that, though, I want to thank you for spending some time with us and offer you a little gift. We'd like to give each of you a $20 gift card. It's basically a $20 gift certificate you can use on the Sweetwater website for anything we sell. If you've got a mobile device, just hold that up in front of your screen, scan the QR code that you're looking at there. That's going to take you to a form. Once you fill that form out and submit it, you'll get an email from us, and that email will have a code worth $20 you can use on our website, sweetwater.com, or over the phone with your sales engineer. So with that out of the way, welcome, everybody. How you doing, Kent?
Doing well.
Good. Let's talk about Lighting 101. I don't know about how many of you guys, but I was not born a lighting person. I'm a musician, and I'm an audio engineer, and somewhere along the way, somebody sat me down in front of a lighting console and said, can you please turn on the lights and make them look pretty? So I had to learn a bunch of stuff about lighting in a pretty short period of time over the last few years. And it occurs to us that a lot of you may be in a similar position where you're a musician or an audio professional and someone has thrust lighting upon you. So we would like to take some time and talk about the basics of lighting, everything you need to know as a beginner to get started when somebody sits you down in front of that lighting console and says, can you please turn on the lights? Let me introduce you to Kent. So Kent is our live sound market manager here at Sweetwater. He's a 40-year veteran in the worship technology industry. The first time I saw Kent was at a Promise Keepers conference in the 90s at Texas Stadium. I was way up in the stands somewhere, and he was down center field mixing a huge console at one of the largest live events I'd ever been to, probably one of the largest live events that had ever happened in that stadium up to that point. He has spent 20 years at First Baptist Atlanta as a front of house engineer, working with Dr. Charles Stanley and In Touch Ministries. He has over 1,000 published articles in magazines and on the internet. It's amazing how many times I need to know something, and I'll go to Google and type in what I'm looking for, and the answer is in an article written by this guy here. He's worked with Integrity Music, Promise Keepers, like I mentioned, Paul Balash, Israel Houghton, and many, many others. And I am very pleased to call him a friend and a mentor. This is my buddy Kent.
And this is my buddy Jeff. And Jeff and I met when Sweetwater was in the old facility back on Bass Road.
20 years ago.
Yeah. And Jeff was one of the first sales engineers, and just took it upon himself to create the entire House of Worship team. So Jeff is in charge of that team, which now numbers almost about 100.
101 as of last week,
okay.
Yeah.
And so about 20% of the sales team. And Jeff has done that. He's also a very gifted vocalist. In fact, when we do things at NAMM shows and WFX shows, which is now CFX, we often use some of his tracks from his a cappella team. He has a beautiful voice. Great front of house engineer, just well gifted, and he and I are both just really learning lighting along with everyone else. And so, well, in fact, with Crowder Calls, and you've seen his new studio, a lot of that came through Jeff, Tomlin, Jesus Culture, just numbers and numbers. If you have an issue and you need something solved, Jeff's your person.
All right. Thank you. So we're going to go back and look at some histories, figure out where stage lighting has come from, and then where we are now and where we're going. The first lighting system I was ever put in charge of had a bunch of these things. These were incandescent par lights. They were hot. They consumed a ton of power. And most of the energy that went into them doesn't come out as light. It comes out as heat. They're very efficient heaters and very inefficient lights, which is actually true of pretty much any incandescent light bulb. They're better at producing heat than they are producing light. And they had one color. It was light colored. The incandescent light that came out of them was sort of this whitish amber color. And if you wanted anything else, you had to put a gel in there. A gel is basically a piece of colored plastic you'd stick in a frame in front of it, and because it's it's just plastic, and these things are basically little heaters on steroids, that plastic would eventually wear out and melt and warp and change colors, and you were always having to put in new gel inserts to maintain the colors. I remember many times standing up on a ladder, putting these little pieces of plastic in these gels, in these gel frames, to just because we wanted the stage to be blue and stay blue. It was so hard. The other big thing about them is that they're light bulbs. They wear out. So you would have to replace the bulbs from time to time. The bulbs were expensive, and usually we put these lights in places that are not terribly easy to get to, so somebody had to climb up on a ladder or a lift or scaffolding and get up there and change all the lights. And I can't tell you how many times I've been into a church where you look up at the ceiling and they've got a bunch of these lights and half of them are out. Because nobody wants to get up on the ladder or pull out the scaffolding to get up to the ceiling and change all the light bulbs. The church that I went to in Waco, Texas, we had I think it was a 60-foot ceiling. And so to get up there, you had to unbolt all of the pews from the floor and spend about 2 days erecting scaffolding, climb all the way up there, change your light bulbs, and then spend 2 days tearing the scaffolding down and putting all the things back. Changing a light bulb was a 4-day job that took a crew of 5 people, and it was ridiculous. So they didn't change the light bulbs very often. When they went out, they just went out, and the stage is dark. Anyway, so that's all the problems. That's why we don't really see many incandescent lights in use anymore. What we've switched to, tell us about LEDs.
Yeah, so like Jeff said, obviously the drawbacks of the old style of technology were just numerous and very difficult. You always had a wrench in your hand and heavy gloves, and everything was hot and everything was difficult and dirty, very mechanically oriented. And then along came LEDs. So light-emitting diodes essentially solved most of those problems. Now, they created new problems, but on the positive side, LEDs have, say, 50,000 hours of lamp life, very small, highly efficient, relatively inexpensive in relation to the lifespan of a conventional light. And they also are able to do some amazing things that we couldn't do with conventional lighting. So things that were just never conceived of. And so as the palette broadened, then the ability to do new things came into play.
Yeah, with LEDs, compared to a comparably bright incandescent light, they put out about a 20th of the heat.
Right.
And so not only do they use less power, and you save money in your power bill that way, but you're not having to counteract all that heat with air conditioning. So a lot of the expense of an incandescent lighting system wasn't really the lights; it was running the air conditioners all the time to counteract the heat that these lights were putting out. So LEDs will save you money on energy 2 ways. They don't use as much up front, and they produce less heat that you then have to fight with AC.
And from an infrastructure viewpoint as well, we're not having racks of dimmers in these controlled rooms and all this conduit that powers out and all of this infrastructure. So we just reduce it because typically we're not going to use an external dimmer on the LED. It simply dims itself.
Right. So from a long-term cost of ownership perspective, from an infrastructure perspective, from an energy use perspective, there's just so many good reasons to use LEDs instead of incandescents. That's why you just hardly ever see incandescent lights being used in new installations these days. Right. The whole world has gone LED for stage lights. So we talked about the power saving, we talked about the reduced heat, talked about reduced maintenance. Colors without gels, that's a huge thing. I can take one light, and that light can be red or green or blue or any combination thereof, thousands of different color combinations, and effectively replace a whole truss filled with incandescent pars, where I'd have a red, a blue, a green par. Now I've just got one light that does all those in various combinations.
All right.
All right, so talking about colors, I do want to spend a few minutes understanding colors and how they mix, and how is it we can have an LED with just 3 or 4 fundamental colors and get so many possibilities out of it.
Perfect.
Right. So your basic LED, the first colored LEDs that we had were red, green, blue, tricolor. Then we added the fourth color, amber, and amber is meant to kind of mimic that incandescent glow, the natural the whitish light that's not quite white that incandescents give us. And then beyond that, new lights have come out with hex colors. That's red, green, blue, amber, white, which is a true white, and then something else. Some of them will have lime, some of them will have ultraviolet, which is all kinds of fun. And those color combinations, if we give you a light that is 20% red, 20% blue, 30% green, and it have all of these various colors mixed in, we can make all kinds of colors beyond just the 3 or 4 or 6, whatever base colors we have. So that really, really opens things up to give us colors that we never could have gotten even with a whole library full of gels.
No,
Right.
on LEDs, initially with the red, green, blue RGB environment, we were missing some steps in there. We were missing, things that would be more flesh tone. We were missing things that, say, peach or a really type purplish green kind of thing. All those, so we filled in the gaps, but LEDs initially had individual red, green, and blue LEDs.
Right.
And you may remember, if you've seen older LED panels, it was just a big sheet of essentially small LEDs spread across there. And so when those shadowed out, they shadowed out as red, green, and blue shadows. And
Right.
we had all sorts of problems.
You had somebody standing against a white background, it looked like a rainbow behind them.
It did, yeah.
Right.
So obviously, since the time we've been able to take the LEDs and put them together and have those segments work in those multicolor environments, and it solves the shadowing problem. Also, the initial LED issue was throw. We had quarter watt or half watt LEDs, and we could only get 15 feet at the most. So we had wonderful up close, but anything that had to throw was always going to be remaining incandescent, source force, those type of things. So having the ability now to have high power LEDs, 18 watt LEDs, things like this, and having multiples of those, throw is no longer an issue, flesh tone is no longer the issue it was, but we still have to decide between this entire cool white, warm white environment.
Right.
So for instance, with In Touch with Dr. Stanley, starting in 1969, of course, obviously we had numbers and numbers of incandescents, and it grew to the point that we had 5,000 watt, 5K units spread across the stage, and it was all illumination for a warm white environment. And then as we have now shifted in LED technology, cool white is becoming more standard, and so you choose between those two because you don't want to end up in a situation where it's a hybrid and the cameras get confused
Right.
and all sorts of bad things happen. The eyes can compensate, but the cameras can't.
That's right. Yeah, our eyes are brilliantly and wonderfully made devices, and human beings are great at looking at something that is white in one light and looking at something that is white in another light. And your brain's smart enough to figure that out and say, well, that's all white. That looks the same color. But really, they're very different colors. And while humans are smart, cameras are dumb. And so if we are putting cameras on our stage and trying to do any kind of broadcast or live streaming, it becomes very, very important to make sure that all of our lights are balanced to the same white. If we've got some older lights, maybe that are from incandescents from a previous install a few years ago, and we've got the new LEDs that we just put in this year, there's a really good chance that those two lights are going to have a disagreement over what white looks like.
Yeah.
So there has to be some sort of compensation there. Either we're going to change the color of the LEDs to match the incandescents, or we're going to install a gel in the in the incandescents to match the LEDs. There are color correction gels that are available to do just that very thing, to make an older incandescent light cast the same cool white that an LED white light would, or to do the opposite, to take an LED light and make it a warmer incandescent looking light.
And those generally fall into the orange and blue categories, and they will do a full, a half, an eighth, or a quarter across those, and being able to work that out. So there are ways to make this happen.
And a lot of the better LED lights, like the ellipsoidal lights, we'll get into the types of lights in a minute, but a lot of them still have the old gel frames on them. So it's possible to take a white LED light and put a gel in it, just like you would an incandescent light. And bonus, since the light doesn't run at 7 million degrees anymore, that gel is going to last much, much longer. You won't have to get up on a ladder and change the gel all the time. Okay, I promised we would talk about different types of lighting fixtures. So we're going to walk through all of the common types. This was one of the first things I had to learn in lighting. What's this called? What's that called? What do I use this for? And when do I need that? So start us off, Kent, with wash lights.
So wash lights, as the name implies, wash a wide area, and they're going to have a broad coverage angle.
Right.
And because of that, they're not going to be specifically oriented to highlighting a certain thing, but giving us a general wash, as you'd want a church stage during the sermon, so that as the pastor walks across that stage, we have consistent illumination, both for the amount and the temperature of it. We can call these floodlights. In the old days of parkans, a parabolic anodized reflector, say a par 64 with a 500 watt flood on it, would basically be a big headlamp and would shoot out like that. The only control is in the barrel itself, where we added barn doors, but it's essentially just a broad environment and allows us to be able to cover that large area and sometimes put some color in there as well.
Sure. Yeah, these are going to be the most common types of lights used in church lighting, because they cover such a wide area with a broad soft light. And the big key feature here that differentiates these from spotlights is that the edges are soft. There's not a clearly defined circle on the floor when you shine a wash light on it, like there would be if you shined a spotlight. These come in a bunch of different form factors and different shapes and sizes. We've got the par lights that we were talking about. Color bars, those are strips that are usually about 3 feet long. Those are really great for illuminating walls, putting backlights on. We got a light behind us here showing the back wall. They're great as footlights or to cover a really wide area. They're not as bright as a lot of the par lights are, so we don't typically use those as primary lights as much as we do pars. There are wireless pars, which are great if you're setting up or tearing down something quickly. You can deploy those across a whole room, use them as uplights on the walls or on columns for a special event. And they're battery powered. It's something we could never do with incandescent lights, but pars, LEDs make it possible to have a battery powered light that'll run for several hours.
It charges in its case.
And
put it in the case, plug the case in.
They're brilliant.
Yes.
And then Fresnels. So in a TV studio, you see a lot of these types of things. This is a light. It was actually, this type of lens was developed for lighthouses, where they needed to cast light over a really wide area, over a long distance, but they didn't want to put a lens that was, on a lighthouse. It would have been several feet thick, and that's an awful lot of glass. So some clever French engineers developed this thing called the Fresnel lens, which basically breaks up a huge lens into a bunch of smaller segments and lets us use a lens, an optical lens, to spread the light over a wide area without having to have this huge, heavy hunk of glass in the front of the light. They are used a lot in studios and stages, and they have their main characteristic is smoothness.
Yes.
Soft light over a wide area, especially if you're doing lighting for video work, for streaming. This is the kind of light that you might want to look at a lot. And just like all of these lights we're talking about, these are primarily LED based these days. You can get them white, or you can get them in all variety of colors. And tell us about spotlights.
Yeah, so obviously the opposite would be a spot or a focused light. So being able to put energy in the light spectrum onto a particular subject, say a soloist or the trio, whatever the application may be, being able to get that intense beam at a distance. So our classic instrument there is the LECO, the Source 4, kind of an instrument where we have a barrel, and we're able to then, in the old days, use an HPL lamp that allowed us in a 575 or 750 watt configuration to cast that energy and then be able to use the barrel of the lens. So we would have 19 degrees, 26, 36, and 50 degree angles, and then be able to put that energy directly where we needed it. Sharp-edged, very particular. You can see in the photo here, especially in the top one, you can see the defined edge of the beam. We can also put gobos on that, which allows us, as you can see in the center right there, being able to have anything from a Methodist cross and flame to anything, a wedding application, anything like that where we need to cast that light into configuration.
make shadows and
Yes.
and pictures and images with light. So coming to this as a non-lighting person, when I hear the word spotlight, I think of one thing, and that's always the Super Trooper
Right.
follow spot, right? And that is a type of spotlight.
Yes.
But in stage lighting, the far more common type is the ellipsoidal, what you're talking about, with a light engine in the back and a focus tube, some kind of optics with a lens in the front to bring that into a hard edge with a defined width, a certain number of degrees in the beam. And I would say behind wash lights, this would be the second most commonly used light. And for key lighting applications, where we got the pastor or any subject that is center stage and that's the primary focus of attention, these are the kind of lights we should be looking for to provide primary lighting for whatever our main subject is. Probably not going to light the entire band with all of these lights, but for our primary subject, ellipsoidals, spotlights are the way to go. And a lot of what is being used, not just in churches, but in the theater world and the concert world lately, is moving heads. Moving lights have come a long way over the past 10, 15 years, haven't they?
So initially, we didn't move the entire light. We moved the mirror. So we had a fixed light and moved the mirror around. And it worked, but they always got out of sync, and there was always an issue. And then we were able to then put the head into a moving XY axis. So we can turn it this way, we can turn it this way. Now we can put that light wherever we need it. And that trickle-down technology over the years has made its way into even small churches. We just want to be aware that it can be fantastic when used properly. It can be overdone.
Sure.
And that sometimes when we have resistance to lighting, it's perhaps because we've chosen to be a little bit indulgent with our movers.
What I like about movers, when we think of what they look like, you think about these pictures you see in the next slide here, lights that look like this, and lots of movement, and it looks dance club lights, concert lights, that sort of thing. But what I really love about putting these in church installations is that one light can do a bunch of jobs.
Yes, that's the key.
And it's not so much that I want to make the light dance around the stage during the sermon, but I want one light that I can shine over here when I want it, or I can light this side of the stage when the kids choir comes up, and then put it on the band then, and we're able to basically eliminate a bunch of stationary lights by putting in one or two of these moving lights.
Yes.
And I think that's probably that's the most practical application in most churches. If you look at the theater world, and I'm talking about like Broadway and traditional theater, you see a lot of moving lights these days, and it's not because they want it to look like a concert. It's because they want to light in a bunch of different places, and they want to do it with as few instruments as possible. So moving lights are great ways to economize a lighting system, especially when you're limited in the number of places you can put these lights physically.
Exactly. And to that economy, we always never want to have a false economy. We'd rather have 4 really good movers as opposed to 12 mediocre movers. And when we talk about that, we're talking about not just the light output, but perhaps the more important aspect is being able to have that light be quiet as it moves and it does its thing, and not be a distraction, both from the fan noise and the mechanical aspect of the gearing.
Yeah, all of these moving lights, they have a motor, a couple of them, that moves the light in different directions, and they've got a fan to keep that motor cool. And some of them are made for DJ applications, dance floors, where noise is really not a concern. No matter how much noise the light makes, it's not going to be louder than the dance music. So if you take that kind of light and you put it in a quiet sanctuary, as soon as the lighting system comes on, everybody in the room hears click as these things start to run. So you have to be conscious about noise from our moving lights. Noise from lights is not a concept that I was familiar with before we started dealing with movers. And finally, we've got these. These are effect lights. So these came to us from the DJ industry and from the theater world, where we want a light to do something special, cast stars on the ceiling, or moving moving elements with a bunch of different colors, or some of them look like water or clouds, or use lasers or whatever. So I would put all of these in the specialty category.
Yes.
Like, use them sometimes for a drama or when it makes sense. This is not the way you want to light the entire worship set.
No.
Probably. I haven't been to your church, but
Probably not. No.
they're fun, though, and they're good to know about. And most of these, honestly, are not very expensive either. So if you've got a special application, once a year you want to pull out the cool light with the lasers that makes the water and does the cool things for a really special application, go for it.
That's right.
All right. These are not really lights. Let's talk about atmospherics.
Well,
What are these for?
So this is a major controversy in a number of churches, is being able, when we have light, light has to hit something to be effective. And so what we see is the reflection, as we have the lights here that you and I are utilizing on camera. And so that reflection then allows us to be able to see what the subject matter is. However, sometimes we want to see the light itself, the beam.
Right.
And again, falling into two camps. One camp says, the haze brings the praise. And so we want it lit up, and we want to see every beam of everything moving.
Right.
And then some churches are rather opposed to that. And so we respect that. But we do want to bring a balance to it, in the sense that you and I have discussed this with our buddy Andrew Scriven, who's in marketing and behind the scenes of all these things we do. That a sunset, as beautiful as it may be, if we take the clouds out of the picture.
Yeah. What's a sunset without the clouds?
Right.
These light beams have to have something to reflect off of, or we can't see them. Another really great example is the morning sunrise in a forest. If you've seen the dew that comes in the morning mist, and the way the sunlight comes between the trees and the branches, and you have these little fingers of light come down. That moment would be nowhere near as beautiful if it wasn't for the mist.
Right.
We couldn't see the sunlight, those rays of light come through. So Haze is a really, really wonderful, beautiful, powerful tool. It is also one of those things that can be, and frequently I think is, overused.
Right, because we look, and often people will be reticent to utilize it because they don't want a fog machine. And a fog would be a very dense, typically low-lying environment that would not be that useful in our application.
Right.
But haze would be broken up and hang in the air. We can either do water-based or oil-based. Each has their pros and cons. But the basic idea is giving the light something to bounce off of and utilizing that in appropriate moments. So if we have a solo violin and we have that spot on the violin and being able to see the beam coming down, that makes complete sense. During the sermon, probably not so much.
Right.
No. So again, it's just being judicious in our use of the technology.
I want to use haze and movers on the announcement about the church potluck next week. Being careful and judicious about it. Haze is something we use a lot. Fog, not so much. Fog, it looks like a cloud. It's supposed to be thick, and it dissipates rather quickly usually. It's just for special moments. And I'd put that in the same category as all of those effects lights, right? They're things you pull out of the closet from time to time, but not what you're going to use every Sunday morning.
And then with haze, there are typically two caveats. Is, again, just like the movers, buying a good one because they're noisy, because we don't want to have that generating all that noise in the midst of this. And the second part of it is being able to make sure that our fire suppression systems, our fire alarms, are going to be compatible with this. What the local fire marshal says, we always defer to safety as the number one rule. So working that out is certainly doable. We do it every day in venues, so it's not a problem, but just being aware of that.
Right. So consult with the people that installed your fire suppression system. You don't want to go setting off smoke detectors mid-service. Okay, so we got fixed lights, we got moving lights, we have white lights, we have lights that can be any color under the sun, and all of these other elements. How on earth do you control all that? And I'll be honest, this is probably, of all of the things about lighting that I had to learn, this is what baffled me the most, because it just seems like so many things that work in so many different ways. How I can't put all of that on a console with a bunch of sliders and expect it to work like a mixing console. I'm coming from the audio world. I'm used to a 24-channel mixing board where every channel is controlling the same set of things. I've got an EQ, I've got a fader, I've got a mute button, and it's 24 copies of the same thing. And if I learn how to do one, I've learned how to use them all.
Right.
And each one of those inputs is the same sort of thing. It's an audio source.
Right.
So I can do the same things to them. But if I've got moving lights, and I've got stationary lights, and I've got some lights where I can change the colors, and some lights that I can't, and some old incandescent lights that are still running from the old install, and they're on dimmers, and all I can do is change the brightness of them. Man, there's a lot of disparate things. So, how, Kent?
Yes.
How do we do it?
In the old days, we basically had, controllers before DMX, and so DMX is digital multiplex. And essentially, if we think of DMX in audio terms or musical terms for musical instrument technology, before MIDI, before musical instrument digital interfaces in 1983, Roland, Sequential, Yamaha, Korg all had their own way of doing control voltage. So we send a control voltage down, we're able to sequence or do whatever, talk to each other. But each brand was incompatible. So then the MIDI came along, and the MIDI working group said, all right, here are the standards. We're going to all talk this same language. Now I can hook my Yamaha to my Korg, to my Kawai or whatever, and it all works. DMX essentially did the same thing. Prior to DMX, Leprechaun, ETA, everyone had their own way of doing it, and it all used a big old ugly multi-pinned in that always fell out, and just it's very difficult. And then DMX allows us to be able to talk the same language. That's the first part of it. Second part of it is, as you mentioned with the audio mixer, you would never conceive of a 500-channel audio mixer.
Right.
It's just impossible. But we have multiple 500-channel lighting controllers, and being able to control all the aspects of the lighting. So if we think about the drum kit as being, 8 channels of drum kit typically with a mic, with the kick, the snare, hat, 3 toms, 2 overheads, and that would then be one lighting instrument. So it's 8 channels of drum in that one light. So we would have 1 channel for the kick, 1 channel for the snare. Same thing with light, 1 channel for the red, 1 for the blue, 1 for the green. So now we break that one lighting instrument up to multiple channels, but being able to control them in a lighting console can be a little harrowing. So you can see, obviously, just on the chart there, being able to assign these things out. And so I'm sure you dealt with the same thing starting out in lighting.
Oh, the first lighting system I ever touched was an old Leprechaun system that used that 5-pin DIN, basically looked like a MIDI cable that was 300 feet long.
And would never coil.
And it would never coil, right. And it didn't matter if we only needed 30 feet of it.
Right.
The rest of it would just be in a big rat's nest behind the stage, because only that cable would work. Right. We couldn't substitute some other 5-pin MIDI cable. That was a special magic cable blessed by the Leprechaun people, and it only that cable would work with our lighting system. But moreover, we could never use anything other than Leprechaun dimmers.
Everything had to be
everything had to be
specific.
there, and there was a hard limit. We could only, I think, have 5 dimmers running on that system, something like that. So there's a really low limit to the number of lights we had. With DMX, every light, doesn't matter who manufactured it, or if it is a simple light or a complex light, if it's something that uses 1 DMX channel or something that uses 50 or 100 DMX channels, we can put them all in the same DMX system. So the way this works, it's kind of like the mailman coming to my house. He's got a bunch of letters, mostly they're junk mail and bills, but he comes and has some that are addressed for me, and he'll deliver the messages that are meant for me, and then he'll go to my neighbor's house and he delivers the messages that are meant for my neighbor. And one mail carrier is serving 50 houses in my neighborhood. And he keeps it all straight. He doesn't deliver the messages to me that are meant to go to somebody else, and vice versa. And DMX is kind of the same way. Every light has a DMX address. And so if your DMX address is DMX channel number 1, then you are going to receive the messages that are meant for DMX channel 1. And all of the other messages that come in simply get ignored and passed on down the line to some other light that will respond to those. So it's not a system where we have to run a cable from our console to each and every light. We can daisy chain these things, which makes wiring way, way easier. And as long as we get the addressing right, everybody, all the messages end up in the right light instrument. So each light needs to be addressed manually. And some lights are 2, 3, 4 channels. Some lights are 10, 20, 30, 50 channels. So if we take this first light and say you're going to respond to channels 1 through 4, and the next light's going to respond to channels 5 through 12, and the next light is going to respond to channels 13 and 25. That's what we're talking about when we say addressing. One way to do that, most lights have some kind of system with a little menu on the back, a little tiny little screen, and up and down arrows and buttons. And you can go light by light and punch the little up and down arrows, follow the instructions that came in the manual to assign each light its address. Other lights are easier, and especially in a large lighting system where you've got a bunch of these things, it is a lot easier to address them automatically or address them remotely from a lighting control system rather than go into each light and punching little up and down arrows, right?
Right. And a number of controllers now have what we call macros or profiles. So if we have a particular Chauvet or American DJ relation, whatever, this particular model has a macro in the system, and I just tell it, I'm utilizing this particular box, it knows what to do. And then within that, we can then assign. So if we were using a batten, say a 1 meter long batten at the back, we can put that in 3-channel mode, red, green, blue, or we might put it in 7-channel mode, and we can then pick and choose amongst our layout of our available channels and say, well, I don't need complete control over that. I'll save those channels if I'm utilizing something later, and I only have one universe. So talk to us about universe, just to be sure.
Yeah, well, we organize DMX channels into universes. One universe is 512 channels. Right. So a single DMX cable can carry information for 512 DMX channels, which could be a couple lights or it could be a bunch of lights. Right. And some lighting consoles, most of the smaller ones, are designed to control one universe. And that's a common ceiling, is 512 channels. It's not hard, though, to conceive a lighting system where you have more than one universe. 2, 3, 4 universe systems are pretty common, especially as we get into these lighting systems, these lights that have 20, 30 channels available. So there are lighting consoles out there, like this one at the top of the screen here. That's a Camsys that will control multiple universes at one time. Very much unlike an audio console where one fader does one channel. Right. In the lighting world, we can have one fader controlling a bunch of things. You know, one fader may be controlling the brightness of 10 different lights, or it can be controlling 5 different parameters on the same light. So we take that 512 channel universe and we can effectively reduce it to maybe 16 faders of things that we need to have our fingers on at any given time. Program those into macros, and we can even extend that more by setting up presets and scenes. So really we're just stepping from different looks. I've got the blue stage, I've got the red stage, I've got things set up for the worship set, I've got things set up for the sermon, and I don't really need to have my fingers on 512 channels in order to accomplish that.
It just makes it much easier.
Much easier.
And we'll mention the Camsys there. We love that product here at Sweetwater.
Oh, they're great.
It just because it operates like an iPad or an iPhone. It's just simple. You can utilize it. Color palette selection is super easy, and it is very accurate. The console that you see below is a more traditional two-scene setup. So the top layer, traditionally, you can run it different ways, but traditionally the top layer would be my lights in this position, and I can then crossfade to the B side, and then while B is up, then I can manipulate A again and go back and forth and back and forth. So I'm basically preview, view, preview, view, and it certainly works. It's just much more time-consuming.
Sure.
And then generally speaking, we're at Sweetwater going to encourage people to look more in a Camsys environment, simply because we've learned over time and through our own use in churches that it just makes it so much easier to do what they want.
Well, it's so much easier, even with a relatively simple lighting system. Right. If you're not doing hundreds of channels, that's fine. But even a relatively small LED lighting system, you'll have a lot more success with something like a Camsys controller than a fully manual controller like that, the bottom one there. So we talked about chaining these. Most DMX fixtures are going to have a DMX input and a DMX output. That's so we can do that daisy chaining. And
we have to talk about the gender being reversed.
Yeah. Well, that's next. Yeah. We'll hit that. We can daisy chain up to 32 fixtures in a row.
And that's variable. That depends on a number of parameters. Sometimes
Right.
things
That depends on the
happen,
lights,
you
depends
know.
on the cable length,
Right.
depends on the
Yeah.
type of cable, what kind of mood the lighting system is
Yes,
in that day. But you can do a whole truss of lights
Right.
with one cable going up to it. So connectors. So if you're an audio person like me, these first two connectors will look pretty familiar to you. Tell me the differences. Why are they not like we think they are?
Well, because they have different impedance and they're wired differently, and you can get by sometimes if you're in a pinch, and it's an event that starts in 5 minutes and you need to hook a light up. Probably the XLR mic cable will work. It is a 3-pin XLR, just as we have here, but it is not made to do that. So generally speaking, DMX is going to be a dedicated, even though it uses the same connector. Those connectors are reversed, so the outputs are female, the inputs are male. Whereas in audio, we're always used to seeing pins. We know that's an output. So it's reversed in that situation. But also, if we have, say, 6 lights in a row and we have 5 of those connected with DMX cable, and the last one we just threw a mic cable on. If things get squirrely, that's the problem. It always is.
So some lights have 3-pin DMX, some lights have 5-pin DMX. There's really no difference other than the 2 extra pins. Those 2 extra pins aren't actually connected to anything. They don't.
Generally speaking, they're not. A few things, but yes, it's a more expensive connector.
It's a more expensive connector. The nice thing about it is nobody confuses it with a mic cable.
Right. It solves the problem.
That solves that problem entirely. If you are using 3-pin DMX cables, though, and you also have XLR microphone cables, I encourage you to mark them clearly. Here at Sweetwater, we use bright orange electrical tape for our DMX cables, so nobody grabs a DMX cable thinking it's a mic cable or vice versa. Also, termination. At the end of those lines, when you've got all of your daisy chain, you need something to plug into that last light to mark the end of the chain. And so a properly set up DMX signal chain is always going to have a terminator at the last end, which is just, it looks like an XLR connector with no wire attached to it. And then finally, the last type of connector we use for lighting is the good old RJ45 Ethernet. This DMX data is just data, and we can put it on an Ethernet network just like any other kind of data. So there's an Ethernet protocol called ArtNet that it basically just takes a bunch of DMX universes and compiles them together, puts them on an RJ45 cable. And in a really large setup, ArtNet is a lot more cost effective than running DMX cables everywhere, because we can just put one run of Cat5 cable and put 100 lights or more on one wire. You got anything else to add, Ken?
I think that's it. I mean, it gets us a good start to being able to understand lighting for non-lighting people, being able to get some ideas. And if we had some more questions, then the easiest ways to reach out.
Yeah, email us. So my email address is Jeff_Barnett. That's JEFF_BARNETT @sweetwater.com. Kent is Kent_Morris. His name's easier to spell. At Sweetwater.com. And also check out the Sweetwater website, Sweetwater.com, and there is a ton of information there. As we have been through this learning process over the past, really, it's been about 10 years now since we started getting into lighting. We have written article after article and put up video after video teaching this stuff. So lots of good learning resources at Sweetwater.com. And if you haven't done it already, don't forget to check out that $20 bonus bucks offer. Just scan that, fill out your information, and we're happy to send that $20 to you as a thank you for spending the last 45 minutes with us. That's all the time we got. So thanks very much. See you soon.
Thank you.
Bye.